Very good evening, everyone. Let me know in the chat. Can you guys hear me and see me? Very good evening, Nilanjan. Very good evening, Ankit. How you guys are doing? Have you guys practiced anything in on Tuesday? Very good evening, Joseph. Yeah, I'm also doing good, Nilanjan. So very excited for today's topic, and we are going to talk about it. The next sorting algorithms. So what about you guys? Have you guys practiced the sorting algorithms which we have discussed yesterday or Monday? Sorry, on Monday. Have you guys practiced all those? I think five or four. Yeah, five algorithms that on that day we have discussed. So we started with bubble sort, insertion, selection, quick sort, merge sort. I hope like on the programming wise, you guys need to see the code, but I'm expecting while in the logic part, like if somebody is saying to you to explain how the selection sort is working or how the insertion sort is working, you guys should be aware of that the logic part, and you guys can explain to anybody. Even in the interviews, if somebody is asking, you are using this sort method here, what if I'm saying this sort method is insertion sort, so how the insertion sort works? If I'm saying this sort method is selection sort, how will you how this selection sort works? So you guys, it's okay if you're not able to write the code, but I'm expecting you guys should be able to answer him on the logical part, that how the, or you guys can also like give them the dry run of like you guys can take some example of array, you guys can give them the dry run of that sorting algorithm whichever is asking. Am I expecting right thing, guys? Very good evening, Ekta. Yes, that's what I'm expecting. That you guys can easily explain there, and I will at the end we have that cheat sheet, right, where we can look for the complexities, all the sorting algorithms complexity. So we could remember those complexities from there, and then we can simply tell to the interviewer that this could be the complexity here with this particular selection sort or with the insertion sorts. Okay, guys. So let's wait for some 1 or 2 more minutes, and then we will start today's topic. Okay. So today, actually, in my area, actually, it's not raining from 4 to 5 days. So now again, I think temperature has raised to 33 degrees Celsius here or more than that. So too much uh, hot here in my place. What about you guys? Is still raining in your areas? It's cold here in Himachal Pradesh, HP. Oh yes, cold in Himachal Pradesh. Definitely, it would be cold, right? Joseph is saying it's rainy there. For Riaz, I think it's also same as me. For Niranjan also. So Ekta is saying that it's raining 20 minutes ago like crazy. Oh, nice. So it will be a little bit less sunny or let's less hot in your place. Not in Delhi. In Delhi, yeah. In Delhi, or I think I am also, I think staying not far from Delhi, I would say. So I think from my place, Delhi is I think near to 450 kilometer. So it's not far from my place. So I think yeah, weather is same. Whatever is Delhi, it's here. Okay, guys. One more thing, just apart from this weather part, have you guys started practicing the questions from lead code? Because while you are see, I like I was thinking, while you guys are understanding these binary search, or because a lot of questions are there with binary search, I have seen that. And I think on that day when I was sharing my screen, I think Ankit has all mentioned that day to solve one problem with lead code. So on that day, we have seen that there were a lot of problem with binary search. So whatever we are doing in class, I think that is only going to create the base for you, only going to create the base, not the whole building. So that's why for creating a building, you have to start solving problems from the lead code. And I would like request to everyone here that please start solving problems from the lead code. Everyone, after doing these classes, whatever logic you understood, try to like remember that logic, and then spend all of your time in solving the lead code problem. Definitely it will help you a lot. And I have seen, like, there was I was like exploring the lead code website, and there was like some people, because lead code provide one more page to you where they will mention interview experience, or let me share with you. I think I will just take starting 4 to 5 minutes, then I think we will start to this session. So let me share for everyone. You guys are able to see my screen? Let me know in the chat. Okay, thanks. So let's open the lead code website. Right, if you open here on interview, let me quickly see where I have seen that part. I think in the discuss, they will have 4 or 5 options. Yeah, this one. So if you will click on the discuss, you will see these all the options are here, like menu wise: interview questions, interview experience, compensation, career, study guide, general discussion, support and feedback, right? So if you will go to the interview experience and read any of the, there are a lot of like Amazon, Google is there, Facebook is there, and other companies are also there, Microsoft is there. If you will just open one of the interviews of any one person, you will see, like, they will say, like in this particular part they are not telling, but they will tell you what type of questions any specific company is asking and how much time they are spending on this lead code website. I have seen, like, I was just seeing some of the interview experience people who has already cracked it, who has already joined and accepted the offer. They are saying like they have solved, I think, more than 200 questions on lead code. Some of the like 100 easy questions, 50 questions on medium categories, on remaining questions are hard. So I like, it is telling you, like, it's like somebody is sharing their experience, and you guys can follow those experience, right? You guys can understand how much importance this lead code website right now has if you want to join a tier one companies like Amazon, Google, Microsoft, LinkedIn. Because people are asking, the interviewer from those organizations are asking questions from there only, from the lead code, or yeah, hacker rank or geeks for geeks also. They all are having the same questions. But yeah, you can see, Nilanjan, in the lead code, how they are giving more options to you, where you can read the interview experience, you can read the interview questions. You like, I find like one URL where they were suggesting, like, for solving the problems, they were suggesting some patterns, right? So like there are some of the specific content which people have created just to follow some of the specific patterns. If you will just know those patterns, you can easily understand the questions. Because when you are in interview, they will only give you 30 minutes. Like in the Google, I'll just take some more, two more minutes. So like in Google, they provide you 45 minutes. I think for SD, like, see, in Google they go with L1, like L3, L4, L5. That's the role they say. So L3 is for SD1. It's similar to SD1. L4 is SD2, and L5 is, I think, SD3. That's how the roles or the positions they have decided in the Google. But in the Google, they are giving only you in each rounds. I think they have 3 to 4 rounds. I was reading the interview experience, so I think four technical rounds are there. Four technical rounds are there, And in those technical rounds, like they in those 4 rounds, they will only the time for that those rounds are 45 minutes for per round, 45 minutes. And in those 45 minutes, they will start asking you questions, right? And I think like their target is to ask 2 questions and two medium categories question. Most of the time they ask the medium categories question, or sometimes they ask one hard question and then easy questions. That's how they goes while in the interviews. I was just reading the, see, I also don't know, I have not given any Google interview till now, but I was just reading the interview experience from there, and I can understand now that how much, if you really want to join the Google, Amazon, or these big companies, so you definitely need to solve these questions. And I was really surprised. People were saying like they have solved 220 questions, or like from the last 2 years they are trying to solve it. So it's like that's how I get to know the importance. They see how much time people are spending there, and then after that they are getting the offers from those organizations. So I would also request to you guys also, after understanding the base from here, please spend most of your time in solving these lead code problems. It will definitely see, and see why they are saying they have spent 100 like 2 years, or like 6 months or more than 6 months to solve the 30, 33 or 34 questions. So everyone is saying in the starting they were facing problems like till 30 questions they solved, they were like looking for the solutions and everything. But after 30 questions they started seeing patterns there. So I would also request to everyone here, like even you have already done the previous like Node.js modules. After that also try to start preparing from there. It's very important if you want to really join a big organization, and I'm expecting everyone wants to join the big organization here, because they have very good compensations, they have very good culture wise also, and they have very good amenities also. So that's why whoever is doing these courses, please spend some of your time or most of your time in lead code just for some months, I would say, and 4 to 5 months, and then start applying for these organizations, or in LinkedIn they will start connecting to you. Okay, so that's what I want to share with you. And I would recommend to everyone, please go through this section here and read about it, how the people are like. I think that the interview experience is the better section. I was reading about here how the people are giving the like interviews, what are their experience are there. So and you guys can go for compensation also. So I was looking, see, for the compensation also. So if you look for Google, very quickly I will show you guys, then we will jump into that. It was not here, but recently I've seen the one of the Google compensation. I'm not sure it's there or not, but yeah, I have already seen this. Yeah, let's see, Google L3 offer. You see, the current CTC is, it's in USD. Not sure about the in INR, but yeah, they have very good compensations. I want to say to you guys. Okay, so please, when you are doing these practice, please start investing your time on lead code, hacker rank, and gigs for gigs is also good. But please start investing your time. Okay. So yeah, that's what I want to share with you, because I was really recently exploring these things. So I thought to share these information with you guys also. Yes, I did some question on binary search from lead code. Yeah, please do most of the questions, not some ekta. Please do all of the questions from there. Once you will do that, like in your fingertips, like you will just do that, and you will get. If somebody is asking some questions on binary search related to that, you will quickly understand that yeah, in this question I could apply binary search, or I can optimize my solution. Okay. Ashwin is saying, yes, sir, there are so many really good articles on lead code, discuss sections like interview experience. Yeah, I also like feel it very nice. If you guys know any other website where we can get the similar like these type of informations, I would really like to explore there also. How is hackering in Geeks for Geek? Yeah, that's nice. They both are good, according to me. Okay. Some people says that you need to find the pattern. It's not most used to solve the hard question. You can do this using medium level. What bugs means. So see, Ankit, I have seen lot of problems. If you got like very bad luck, if you sometimes people got very bad luck also. I was reading there only in the interview experience. They were saying I got very bad luck, so I didn't get I got very hard question which was very unique. But at the end, when I was reading the comments, like in the suggestions, like while sharing their experience, they mentioned the questions. But in the comments, people were saying this question relates to that one, this question relates to this one, this hard category. So it means most of the questions whichever an interviewer is asking, somehow they relate with the questions which we have already done. Somehow like they twist some of the information on that, and we just got confused. We have not seen that, we have not seen any problem like that earlier. So that's how happened, but it's happened only when you have very bad luck. But yes, most of the questions I have seen, they are just following the patterns. What perks means? So perks like the benefits. I would say the perks mean the benefit, extra benefit apart from your salary. Apart from your salary, what are the extra benefits these bigger organizations provide? Right? So like they provide you some bonus while joining. They provide you some stocks, right? Which will be like for the 4 years. And apart from that, they provide a lot of health services to you. I think in the Google they provide you, like if you go to the offices, they will provide you free lunch, free foods, these type of things. And yearly they were incrementing also. I think they this all mentioned in their while in the job requirement or job descriptions. So these are the extra perks apart from your basic salary they provide you. Riaz is saying which is the most important competitive programming or development experience? Sir, which is most important, competitive programming or development experience? I think both plays same role, development experience as well and competitive programming as well. Because see, if you are applying for Google's or like Amazon or Microsoft L3, sorry for SD3, they will look for both your development experience as well as competitive programming. So till there will be 3 rounds which will be fully focusing on the competitive programming. Then in the last round there will be system design where you can only answer when you have development experience, right, Riyaz? So it matters both. But yeah, for the SD1 or SD2 role, I think competitive programming is more. It could be leading or more in the priority for joining this organization, not the development experience. Okay. Thanks for producing a quick question. Can I please ask before the class? Sure. Interview would has so many free articles on CS concept. Okay, thanks Ashwin for saying that. So everyone can read the Ashwin message. So he's saying that interview bit. It's a one website where you guys can get a lot of free articles regarding the CS concept. So I will request to everyone just look into that website and follow that. Yeah. Yes, sure. Let's start. Before that, I think Ekta has one doubt. So, okay, sure, Ekta. So I think Ekta has doubt, so we can discuss that later as well. Okay. So let's start today's topic, guys. Okay. Yeah. So today's topic is, guys. Can you guys see the screen or not? Like the slides one which I'm sharing. Okay. Thank you. Okay, so today's topic is, guys, count sort and bucket sort. These are the two sorts which we are going to discuss it today. Okay, so if you guys remember in the sorting class, like the first class of sorting, when I was looking at the slide, they have mentioned that we can do the sorting with 2 ways, right? The first was the comparison based sorting, right? In that comparison based sorting, you can see that we were trying to compare the elements which we got in the input. In the input, if we got 5 elements in array, we are trying to compare all the elements in that array, right? And then based on that comparison, we were trying to sort it. Somehow we were trying to apply some logic, like in the bucket sort, we were trying to look into the neighbor elements. In the selection sort, we were trying to find the minimum one, then trying to keep that into the first position. In the insertion sort, we were trying to go to the left side, right? Whatever the minimum is there, we are trying to put it into the first position. In the quick sort, if you remember, we have taken the mid element, the pivot element, and then we have the 2 indexes I and J. We're trying to move from left to right and trying to break our array into 2 parts, and then again trying to do the similar thing. And in the merge sort, if you guys remember, we try to we try to break our whole array into two parts. Then we are trying to compare it. That's what happening on the comparison algorithms. And these 5 algorithms are the comparison based algorithms. But from now, what we are not going to read the comparison algorithm. These algorithms, I think these are 3 algorithms: count sort, bucket sort, and there is one more Radix sort. I'm right now remembering these 3. There could be more, but I remember these 3. These 3 algorithms are not comparison based algorithms. These are the algorithms where we are going to look for some other informations which are provided in data. Earlier, whatever data you are providing, we need to do comparison. But right now, in these 3 algorithms, we are going to analyze the data first. We are going to understand the data, and based on that data, we will try to apply the logic, and then we will do the sorting. Okay, so this time, first thing, we are not going to do the comparison. We are going to analyze the data which has been provided to us. Like in the some of the scenarios, you might be looking for, like the data should be all uniform, right? Or in some scenarios, you might be looking for we could look for the frequencies, how many times any number is coming in the array, right? Then we can count that, then we can count the number of those elements which are available in the array. Then based on that, we are doing the sorting. Okay, so these algorithms, these 3, like count sort, bucket sort, and the Radix sort. These algorithms are mostly known for giving your time complexity to the linear number. Like in the end in the, like, because see, in the quick sort, if you remember, on the comparison based algorithms, you guys might mostly observed, most of the time we were getting n square, or the best we have reached, which was n log n, right? In the quick sort, in the merge sort, we might get the n log in some scenarios, correct? But in these 3 algorithms, we will see that we are going to get our time complexity n only, n or n plus k, where n would be the greater, and k, we will talk about that. Okay, so that's what these algorithms, and we will try to understand how we are trying to solve these problems. And see, and these algorithms are also going to be apply in only some of the scenarios, in not all of the scenarios. Okay, and yeah, one more thing about these 3 algorithms, that these 3 algorithms all most of the time take extra space. Always extra space complexity is greater for these 3 algorithms. See, this is very simple rule. If you want to reduce your time complexity, you have to compromise in the space. And if you want to reduce your space complexity, you have to compromise in the time complexity. That's the very, like, simple funda, correct? So that's what these 3 algorithms. We will see that while we will discussing about these 3 algorithms, we'll see that we are going to use a lot of space there. Okay, so let's see what they mentioned in the slide. So I think they are saying again about the, I think, comparator, which we have done in the earlier classes. They are telling about the sorting. What the sorting means is, like, we can organize our data in one order. That order could be ascending or descending. That's what they are telling. So they are again telling these type of algorithms does not work on the comparison basis like other sorting algorithm, right? We already discussed this part. Okay, let's move. Let's see in the next slide what they're discussing here. Okay, so the first algorithm which we are going to talk about, that is going to be count sort. And I will say you guys, in all these 3 algorithms, count sort, bucket sort, and Radix sort, count sort is known to be the fastest. Count sort is known to be fastest to solve the problems. Okay, guys, and we also use count sort as a sub sorting mechanism in Radix sort also. In the Radix sort, when we will see the Radix sort, at that time we'll see that count sort is also the part of Radix sort. Okay, so that's the one thing which we should know about the count sort. And let's read about this algorithm, what this algorithm is saying. Then we will see the example here. Okay, let's see. So it is a very efficient sorting algorithm. They are saying works good in the range of data. Here we use an array to store the frequencies less count of elements, then sort. Okay, let's jump directly into the example, and from there first understand this how the count sort is working, okay, and then we will understood what is the frequency here, what is the count meaning here, and what exactly they are telling. Before that, we will not able to understand these things. So let's first jump into the example, and then we will read the theory here. Okay, guys. So let me share my screen. Okay, one more thing, guys. In the code which they mentioned in the slide, they have given because see, I already told you earlier, we can solve the same problem with different ways, right? So in the code, they have tried with some other ways, but we will discuss that way also, how they are doing. But let me try to first tell you in an easy way how the count sort is working. Then we will try to understand how they are doing, because it was little complicated how they have been done in the slides. Okay. So let me first share it and explain to you in an easy way. Okay, so first let me know in the chat, you guys are able to see my screen? Okay, great. So let's write it count sort. Is it late today or okay? Yeah. Oh yeah, it is little late today, huh? Okay, 1 minute. Let me reset it. One minute, guys. I think my pen is little bit slow today. So I'm just looking into that why it's happening. Now the pen is here. Okay, weird. Okay. Let me open a new page. Might be some problem in there. 1 minute. Let me reopen the OneNote. This could be the reason why it's not working properly. Okay, I think it's not working properly today. So let me come back to the here and let's see in the uh, 1 minute. Let's see here in their slides. Okay, is it working here or not properly? Let's add a slide here. Oh yeah, it's not working today actually properly. What's happening? 1 minute, guys. Let me just clean it a little bit. Might be possible something is. I have not checked this before class, but yeah, in the next time I will check it before class. So we might not see these problems. See, it's little slow today. Not taking it properly. Okay, let me try to write it. So let's take the first example, which is going to be which they have given in the slides. Okay, let me write it. So 1, 4, 2, 3, 1, 1. You see, it's taking very slow today. Not sure what is happening here. You can see that, right? I have taken written one array 1 4 2 3 1 1. Can you guys see that? Okay. So what is next thing which we are going to do, guys? We are going to take the maximum number from that array. We are going to take the maximum number from that array. What is the maximum number here? So our maximum number is here 4. Oh, it's very weird actually. Can't. See, I cannot write things today. It's very weird today. Okay. So maximum number is 4, right guys? So what we are going to do, we are going to create a new array which is going to have indexes more than 4, which is going to have indexes more than 4. And why we are going to do that? Because guys, we are going to count how many time these element exist, and then like see, if there is 2, let me first create the indexes, then you guys will get to know why we are doing that. I'm trying very hard guys to write this, but let's see. Okay, so let's take first index, which would be 0. This would be 1. This would be second. I will tell you why we are doing this, guys. And you guys automatically understand this thing. 3 and 4. So guys, why we have created an array which is more than 4, more than the maximum number of this element, because we can keep the count of those elements. So see, 4 is coming one time, right? In the array, 4 is coming one time. So what we will do, wherever 4 index is coming, we'll write 1 there. Understood, guys? Now you can see 2 is coming one time. So wherever index is 2, that's where we will write 1. Now the other number is coming 3. How many time it is coming? One time. So wherever index is 3, we'll keep the 1 there. Now let's look for 1. So how many time 1 is coming? 3 times. So what we'll do? 3 here. Correct? 0 is not coming. We'll keep 0 like that. Understood, guys? That's why we have first taken the maximum number from the array, and once we have taken the maximum array, we will create a new array which will have just one more index than that array. And why we are doing that? Because you can see whatever elements exist, whatever element we got in the input, we want to write the frequency or the count for those numbers. That's why you can see wherever number 4 is coming, I have just the count of that number as a 1. Wherever 2 is coming, I just have kept the count as a 1. See, if in our picture, if in our array 5 is also coming, then what we will do? If here 5 is also coming, then what we will do? We will take one more index here, just to keep the frequency or count of that element. Correct? We use a similar concept in anagrams words also. Yes. There also, like whatever similar words are coming, we'll just keep the count of those letters in the anagram also. Right? So that's what we are also doing here. Okay, guys. Till now, are we good? Till now, are we good? We have what we did. We have just counted it out, all the elements which we got in our array. Okay, sure. Let me repeat it, Nishant. So Nishant, you can see, sure, Nishant and Suraj. Oh, you lost network. I lost today my pen powers, so I'm not able to write it properly. So yeah, no problem. Let's try to understand it again. So see, guys, we got one array, and that array is 1 4. This is our input array. I'll try to draw this also. This is our input array, guys. The first one, okay, this one, where the blue arrow is there. Okay, so the input array is 1 4 2 3 1 1 5. How many elements are there? I think 3 3 6 and 7 elements are there. Okay, so what is the first thing we need to do? We need to find it out the maximum element from that array. Okay, and the maximum element in that array is 5. So once we find it out the maximum element from the array, what we'll do? We'll create a new array. Why we are creating a new array? To just keep the frequency of those elements in that array. When I'm saying frequency of those elements, it means count of those elements. It means how many times those elements exist in the array. How many times those elements exist in the array. And when we created a new array, so whatever the value of element in the array, we will keep the count of that element in the index of that array. You can see in the index of new array, you can see element 4 is there. How many times 4 is there? One time. How many 4 is there? One time. So what we did in the new array, this is our new array, guys. Let me show you the new array also. So yeah, this is our new array. Oh, great. Not able to write it today. Very weird. Not sure what is happening here in the. I'm not sure where is the problem. So yeah. So this is our new array, guys. I'm writing it as a n. Okay. This is our new array. Okay. So you can see here in the new array, whatever element we have in our original array, we are going to keep the count of that array in the indexes of new array. You can see 4 was coming at one time, we kept 1 as 1 at the 4th index. 5 was coming as there, we kept the 5 count as a 1. You can see the for the 1 was coming 3 times, so at the 1 index we kept the 3 here. Yes, it looks like it's something is problematic here. I'm not sure what is it. You see, I'm not able to write it today. Very weird. Okay, guys. So now we understood what why we have created the new array. So we have created the new array just to keep the frequency of elements. Okay. Taken pencil. No, actually, this was actually this is the pen which comes with this. What is that? Wacom. This is the like device which we connect to our system, and then we write it here. But today it seems like might be nif. We have to change it. I will check it after the class, and then we will see that. Okay. Okay. So now, guys. So yeah. So now, guys. So we have taken the new array and we have counted. So understood this part. We understood. Let me know in the chat, guys. This part we understood, everyone. Okay. So now what we need to do? Now what we need to do, guys? We need to take two variables here, or two index, like two flag or two variables here, which is I comma j. I comma j. Both will start from 0. Both will start from 0. Okay. Both will start from 0. Okay. So what we need to do now, guys? We need to check in this new array wherever the value of element, wherever there is not 0, wherever the value in this array is not 0, we need to take that index. We need to take that index that many times. We need to take that index that many times. So you can see, first we taken 0 from here, 0th index. First we have taken 0th index. At the 0th index, there is no value. So we will not touch this element. It means in the original array, there was no element. That's why we didn't get any frequency here. If in the original array, there was any 0th element, we should be getting 1 here, right? But that's why our check would be like that. Wherever in this array, this new array, wherever element is 0, we will move to next index. Wherever element is 0, we will move to next index. Okay, now let's move to next index. Next index is 1 and frequency is 3. So what we will do? First, like in our output or wherever you want to do, first we will print this index 1 and then we will reduce our frequency 1. So now this frequency will become 2. First time we printed 1, now our frequency will become, we will reduce the frequency to 2. Again, we will not leave this index. We have to make all the frequency now 0. We have to make all this frequency 0, and till now we have to continuously iterate in the same index. So now again, in the same index and the same index 1, we have the frequency 2. So what we'll do, we'll again print it out 1 again, and we'll reduce again this frequency to 1. Again, we'll reduce this frequency to 1. Again, we will reduce this frequency to 1. Okay. Now again, because this index is still not 0, so what we will do? Again, we will print it this index, and then again we will reduce the frequency. Now this frequency of 1 will become 0 here. Correct, guys? Once the frequency of this index is 0, we will move into next index. And next index is 2. So we will first print out that index and then reduce the frequency of that index. So now this 1 will become 0. Again, we will go for next index, 3. Again, make the frequency to 0. Now again, we will go for the next index, 4. Again, we will make the frequency to 0. Again, we will go for the next index, make the frequency to 0, and we'll print it out. And as you guys can see, this is our final array, which is sorted. Right, guys? This is our final array, which is sorted. So Likit is saying about the code, how we are going to write the code. So Likit is saying, understood, I for looping in new array from 0 to new array dot length, and j from 1 to new array. J from 1 to new array. So j we will use, j we can use for indexes also. For the indexes in this array, in the below array, we can keep the j there. Because we need to, in this array, we have to increase the j value. Because you can see, Likit, first time j would be 0. So at that place, we'll keep first 1. Okay, because I'm not able to type it today, so that's why it's very weird. So 1 minute, guys. So how the I and j will, okay, first let me repeat it this thing, then I will tell you how the I and j is working. Okay, everyone. So see, again, let me first erase things. Let's go back to the earlier scenario where, let's go back to the earlier scenario when we have created a new array and counted the frequency of each element. Correct? So we can see, we can count the frequency of one index, which is in this original array 3. So 1, 2, 3. So we'll write this 3 here. For the 2, it was 1. For the 3, it was 1. For the 4, it was 1. For the 5, it was 1. Okay. So now what we are going to do, we are going to look into this new array which we created, right? And wherever element is 0, we will move to next index. Wherever in this array our element is 0, we'll move to next index. So now you can see at the 0th index, the element was 0. So we'll move into next index. Next index is 1 here. Correct? So now what we need to do here, we have to be in this index until we make this frequency to 0. We have to stay in this index until we make our frequency to 0. Okay? Until Nilanjan is saying repeat, didn't get it. So Nilanjan, see, first thing what we need to do in this new array, we have to check for the indexes where element is not 0. First thing, we need to check in this array where element is not 0. So first index element is 0. We will skip this one. Understood? Till now you understood, Nilanjan? Everyone understood this, why we are skipping the first index? Right. Okay. Now everyone understood why we are skipping the first index. Now let's jump into the next index. This is not 0. So we do not need to skip it. So what we need to do in this index, we need to make this frequency to 0. And how we will make it? We will subtract it 1 by 1. So first 3 minus 1, then we will got 2, then 2 minus 1, we will get 1, then 1 minus 1, we will got 0. That's how we need to subtract it, this frequency value here, and then we need to make this index also 0. Otherwise, we will not move ahead. Till we make this index value 0, we will not move ahead. Understood this line? Everyone, Nilanjan, Joseph, Suraj, Arad, understood this line? Till we make this index value 0, we will not move ahead. Okay, and how we will make it? We will reduce 1 by 1. Okay, so that's how. So as we are reducing it, we will also print our index. So you can see, first time it was 3. So first time we printed our index, which was this 1. Correct? Next time we reduce this to 2. So now this 3 will become 2. correct? Now this 3 is 2. Now we will reduce it to, now we will again print it. Now the second one is coming, correct? Now again we will reduce it to 1. Again our index will printed it out. Now we will make it 0. Now we will not print it out because now our value is 0. Now once the value is 0, we will move into the next index, which is 2. The frequency was 1 here, so that's why we'll make this 1 to 0 and we'll print our 2 here. Same goes for 3, same goes for 4, same goes for 5. Understood, everyone? So Riyaz is saying, suppose if we have array and max value is 10 lakh, then what? Yes, that's very nice question. And I think in the slides, they have mentioned it. If you see in the slides, you have mentioned that here the range is different between the minimum and maximum element in the array. It cannot be greater than 2 to the power 32 minus 1 as the maximum size of an array in JavaScript. So in JavaScript, you can have only, there is one limit. We cannot keep that much big values. I think 10 to the power 6, it's still possible. 1 lakh is 10 to the power 6, I think, right? 10 lakh is, I think 1 lakh is 10 to the power 6. 1 lakh is, I think, 10 to the power 5, or 10 lakh is 10 to the power 6, right? Yeah, 10 to the power 6. So 10 to the power 6, I think it is possible. You can look for the condition. So they are saying whatever the size maximum an array can have, that much number you can have. Okay, everyone? That's what the limitations. So these count sort algorithms are not going to work for all the scenarios. That's why I told you count sort, Radix sort, bucket sort, they bring their own flavor. Whenever we are going to apply these count sort, Radix sort, and bucket sort, they come with their own flavor. And these three algorithms will only be applied to those scenarios. These type of algorithms we are not going to apply it in every scenarios. That's why most programming languages also, like JavaScript or Python or any of the, like most of the, like whoever has already created the sort method, they are not using any of these advanced sorting algorithms, count sort, bubble sort, or Radix sort. They are using, I think, quick sort, merge sort, these type of algorithms, because those work in all the scenarios. Understood, guys? Let's now quickly look into how the I and J loop will work, which Likhit was asking. Okay, let's see. I'm just praying my pen should work properly. Okay, now what we'll do, guys, we'll start I. So we'll keep our I for this array and J for this array. You can consider this is another array, right? This could be another array where we are going to keep, or same array. We could say same array. In this array, we are going to do that. Okay, let's see. First, I would be 0. Oh wow! Now pen is working properly. Now, nice. Oh, I think God has heard us, guys. Now pen is working properly. Yeah. So see, I is equal to 0, J is equal to 0. Okay. I'm not getting OP. Output, you mean? Not getting Suraj, you mean output, right? Oh yes. So this sorting technique will not work for negative numbers, right? Why not? Let's see why not. Because what we need to do for negative numbers, let's see. Oh yes, that's right. That's right. But see, what we can do, we can convert that negative to positive, and then we can keep those indexes in the array. That's the way we could try here. Guys, I think, see, Ashwin has asked very nice questions. This is for everyone. This is for everyone. He said that if somebody is providing us negative numbers, will this algorithm will work there or not? So the answer is definitely not, because the problem would be the new array which we are creating, how we will find the indexes. If somebody has provided -4, -3, what will be the indexes for them, right? So, but there is one way to do that. What we can do, we could try to convert those numbers to positive and then look for those indexes. Then we can look for those indexes. But yes, we need to do some extra logic for applying this advanced sorting algorithm. But yes, there would be some edge cases which we might need to look. But there is a way to achieve the for negative indexes also, for negative numbers also. Okay. Like is saying yes, no negative index. Can't we do negative of them? Yes, that's what I'm telling Joseph. Then we can retrieve those negatives. Yes, yes. Then we can't retrieve those negatives. Oh, we can. We can lick it. Because we know that all the positive index which we have taken. But yeah, they see there could be one problem. See, guys, yes, I think see the problem would come here when we have positive and negative both indexes. When we have positive and negative both indexes, in those scenarios we might get the problem, because see if there is a -2 and +2, both are there, then we will get the problem there. So that's what. But yeah, if you talk very simply, it will be very difficult to achieve the negative indexes here. But yes, if we could keep some constraint there, like the all the negative numbers has to be added there. But yeah, I think it would be little bit difficult to achieve for negative index, if I say truly, because there would be some of the scenarios where the negative could create some problems. Correct. So, sir, but counting sort mostly focuses on 1 to n range of numbers. Also, another variant of count sort works well with the negative numbers. Yes, yes, that's right. Sir, I think we can create a new array for specifically negative numbers, then merge them using logic. Ashwin has given a nice idea also, like he's saying, we could create two arrays, one for just for tracking the negative numbers, and another for tracking the positive numbers. And later on, we could merge it. Yeah, I think that might be possible. Might be possible. Could we use hashing kind of thing for negative values? In that case, we may use a map instead of array. Uh, for negative numbers, yes, I think we can create, right? Let's check it quickly. I think we can create a map for that key value pair. Yes, I think that's that. Let's see. Let's see quickly. I think we can do that. So that's what. See, guys, the another way people are suggesting here that we could try this also, right? So let's create a simple object. Let temp is equal to this is our object, right? Let's see. We are assigning right now the positive number there, right? Let temp1 equal to this could be the 2, right? Let's see. Temp is giving us positive number. Let's see if we can assign -1 also. I think yes. Let's see. Is it possible or not? You guys can see 1 and -1 both are coming. So yes, with the mapping, I think definitely we can achieve it. But yes, if we will use this object or map, they will definitely increase the space complexities. But yes, we can achieve it. Okay. Okay, so let's see very quickly how the I and jth loop is working. Okay, then we will jump into the code, and then we will see how the code is working. Okay, guys. So let's see. So I is equal to 0. We will start I from this array. So I is equal to 0, and we'll say that we will see that like we can put our condition, like this could be an array, like this could be a new array. So our condition could be new array I greater than 0, then only go inside the loop, otherwise I plus plus, otherwise I plus plus. So now here the element of this index is 0, so we'll go into the next index. Okay, now I is equal to, now I will become 1, right guys? Now I will become 1. Now value of I is 1, right? So now what we'll do, in the 1 inside this loop we will go, inside this condition we will go, and now here first time we will use the j index. First time we will use the j index. wherever j is equal to 0, at j, wherever, like whatever the index is 0, keep the index of I here. So like it will look like this is a like result array. We can say this is result array. So result of j is equal to I. Correct, guys? Right now I is 1, so we'll keep the 1 here, and then we will increase j plus plus. Then we'll increase j plus plus, because at the 0th index of j we have already kept the first element. Then again we'll go for j plus plus. Now our j will become 1. Now we need to find the element for j is equal to 1 index, which is this 2, 3, 4, 5, 6. I have kept all the indexes here. So that's how our j will be increased. Now in the I see, guys, we will not increase I now. We'll again check for for the same I index. For the same I index, we'll again check, is it greater than 0? Yes. But now we have the frequency of this is, because now see, after doing these two, we'll also reduce the frequency, or like rather than writing the frequency, three things we are going to do inside this code block. First, we are going to assign result j. Second, we'll increase the j plus plus, and third thing, we are going to reduce this frequency also. So right now it's 3. Now what we will do? A new array I is equal to new array I minus 1. These three things we will do inside this loop, and then again I will still be 1. Again we will go inside this loop. Again now the j will become 2. Now j will become 2. I think in this one page I am not able to explain it properly. J will become 2. Now j will become j is already 1. Sorry, j is already 1. We have kept this element again 1, same index of I, which is 1. Then we'll increase j to 2. Now j become 2, and then we'll reduce of frequency to 2 to 1, and then we'll go for we will go again inside this loop and inside this condition, and then we will keep the next value of I, which is again 1, at the next index of j, which would be 3, which would be 2, and then we will increase j to 3, and now I will become 0. Now we will increase I to 2, and then we will look for this index. That's how I and j is working. I'm not sure, are you guys able to understood this properly, how the I and j is working, or do you want me to explain it again? I will go to next like new page in OneNote, and there I will explain it. Tell me first, are you guys able to understood this, how the I and j loop is working here, or you want me to repeat it again? Okay, repeat once more. Sure. I think in this one page I'm not able to explain it properly. Let me share my screen and let's go to the. We'll copy things from here very quickly. Our array is 1, 4, 2, 3, 1, 1, 5. I think that one is needed only. You guys are able to see my screen? You guys are able to see my screen? Let me know in the chat. Okay. We need 1, 2 loop, one for traversing I and the other for keeping a count for array frequency I, right? I think in one loop we can also achieve it. I'll show you. Okay, 1 minute. Let me explain this again. Then we'll go from there. So our array was, let me see, guys. Now I'm praying this should work. Now where is my pen? How will I get the pen here? One minute. Hey, still it is working. Okay, let's go to draw. Okay, we are in the draw. We got the pen. Okay. So yeah, so our array was okay. Yeah. So array was 1, 4, 2, 3, 1, 1, 5. Right? That was our array, right? Let me know let me check in the chat. That was right? That was only our, yeah. Then what we did, we find it out the max element. Then we find it out the max element, which was the 5, right? Then we created a new array here. It's still that, like, my pen is not working that much good. Okay, and that new array would be max plus 1. The size of this new array would be max plus 1. It means 6 values we'll have to insert here, and we'll see the indexes here. So 0, 1, 2, 3, 4, 5. That would be our array. Let me try as max as I can try. Yeah. Okay. Now what we did next? We have to count all the elements in the original array, how many times they are occurring. So right, you can see 5 is occurring one time. We'll keep the value here. That would be frequency or count. Okay. How many times 4 is occurring? One time. So 1 would be here. How many times 3 is occurring? One time. So 1. How many times 2 is occurring? One time. How many times 1 is occurring? 3 times. 0? No. So it will be 0. Okay, guys, that's the new array. Now what we need to do, we have to take two variables, like variables here, I and j. Okay, guys, j, what j will be tracking? J will be tracking our result array. Now I have created one result array. You can consider the length of this array is same to the like we can say same to the this array length, original array length. Okay, same to this original array length 0, 1, 2, 3, 4, 5, 6. Right? 6 element are there 3, 3, 6, and 7. So yeah, 7 element and 6 index. Correct, guys? That's our final array where we are going to keep the results. Okay. Then I told we will keep one condition here. Okay. Then we'll keep our condition here. And I think our loop could will be this while I is less than this new array length or max. We can say max is 5, yes, where I is less than max, because we have to traverse all these elements only. That's why that loop we need to put. And then there could be one if condition which would be saying that new array length, wherever new array length is greater than 0, only go inside then in this if condition, else I plus plus. See guys, still my pen is not working that much good. I cannot write properly everything, right? Yeah, but yeah, you guys can understand it, right? This is new array I. So what I did, I'm just putting one first condition as my I loop. This loop should run till my till my length is max, till my i's value is less than max, So I think it will run for 0, 1, 2, 3, 4. Oh no, it should be equal to also, because I want to go for 5 also. So I less than equal to max, right? Then see the first. Now let's see first iteration. We have to run this code, guys, and I will tell you there will be 3 lines will come inside this if loop also. So see, I is equal to 0, j is equal to 0. So now new array I, which is 0, is greater than 0. No. So that's why it will go into the else condition. And now our I will be incremented. So now I will become 1, j is still 0. And guys, j will track this array. Okay, j is still 0. Now the second iteration would be new array 1, because I value is 1. Is greater than 0? Yes, it is. You can see it's 3. So what we need to do first thing here, guys, now I'm telling about these 3 conditions. What we need to do here, we have to in our result array at the jth index, and right now j is 0. So at the jth index, keep the value of I. Keep the value of I. So you can see result 0 inside this loop, result 0 is equal to 1. This is our index of I. So in this place, 1 will come. And then the second line which we need to do here, j plus plus. J plus plus. Now our j will become 1 here, because we need to now try to find the element for first index. The third line which we need to do here, reduce the frequency. Reduce the frequency of that index. Right now it's 3. Now reduce it to -1. New array I minus minus. This will reduce this by 1. Now this 3 will become 2. Correct? Now this 3 will become 2. Now again we'll go to this line. Now this condition ended here. Again we'll go to this. Again it is checking I less than equal to max. Yes. So now again I is equal to 1, but now j is equal to 1 because we have incremented j to 1. I is still it is 1. Now again, is new array I greater than 0? Yes, it is 2, right? It's still greater than 0. So what we will do, we'll again do the same thing. Same thing, this thing, result 1, because our j is now 1. Result 1 is 1 and j plus plus, and then new array, new array I minus minus. Correct? So what will happen here? It will come result j is equal to result j. This is j, guys. Result j is equal to 1, which is 1. And then we will reduce it to 1. Same goes for again I is equal to 1, j is equal to 2. Same thing will happen here also. J will take again 1 and this 1 will become 0. Right? Now this condition will fail. New array I greater than 0, it will fail. It will increment I plus plus. So now what will happen? I is equal to 2 and j is equal to 3. I is equal to 2, j is equal to 3. Now I is equal to 2, index is 2. So that's why we'll keep in the of j, which is 2, and we'll reduce it to 0. The same goes like that for further scenarios also. And then slowly we'll keep all the elements here, 3, 4, 5. And then this would be our output where we have sorted it out. Okay guys, understood this part? Instead of if, we can take while. No, actually, why we need the while here? Oh, okay. You can say, you're saying, yes, actually, we can take the while also there. That's right. So till now, new array I is greater than 0, and result j is equal to I and j plus plus, and I mentioned. Yes, we can take the while also. That's right. That's right. We can try with while also. It will also work. So everyone understood, guys? This part. Let's see in the code now. Okay, let's see in the code. Nishan is saying, sir, what is the use of this sorting method? It's in more difficult than the previous one. Oh, doesn't I personally feel this one is very easy compared to the previous Nishan. Because in the previous one, see, in this one it's very easy. You just need to count the frequency of those elements, and then you need to run the loop and then reduce the frequency and keep the elements. Did you guys see, apart from Nishan, I want to know from everyone, did you guys see this algorithm more complicated than the previous one? Yes, Vishal. So use cases of these sorting algorithms are when we have range and when we do not have any restrictions on the space. On those scenarios, we can directly use this algorithm rather than going with merge and quick sort. In those scenarios, we can use they have their own flavor. They have the flavor. If you are okay with the flavor, you can apply this algorithm. Otherwise you have to go with the previous one. It is reducing time complexity. It is reducing. Okay, so let's talk about the time complexity, guys. In earlier algorithms, we were getting n square, right? In everywhere. So see, this is the first. Here we do not take any of the complexity. This is just simply we have iterated into this loop. First time, n complexity. We just iterated into this loop and created the frequencies here. This is n time, right? Next time when we are doing the second iteration, it is just the size of this array. Size of this array. So it is again, we can consider the size of this to k. So this is just like n and k. There are two things. So like the time complexity is here n plus k. It's a linear time. It's not like we are just going into the multiple loops. Time complexity is better here. Likhit is saying, so very easy compared to last one, too easy to be taken seriously, but is easy to understand. Yes, it is. But time complexity will be n plus max element multiply by max repeated element. Max repeated element. No, no, no. It would be, I think, just the max element. And max element, see, guys, this max element is not that much problematic here, because the problematic thing is here the length of this array. This length of array. See, in this array, we can have like 10,000s also here. We can have 10,000s here also, but this will not be problematic until the length of array is too big. Until the length of this array is too big. If length of this array is 10,000 element, then while iterating it, that will take more time rather than creating the array. Creating the array is very easy. Creating the array in JavaScript or in languages is very easy, but iterating part is complex here. So that's why if you will read the documentation and anything, the problematic is here the length of array. That length of array should not be bigger here. If that is going to be bigger, then time for time for sorting is also going to increase. The max element does not matter that much. Okay, the max element is not going to matter. See, I will show you one more solution where they have reduced the, see, this is one way to solve this problem. This is one way to solve this problem. In the slides, they have given one more way where they have taken the range. What they have done in the other example, guys, they have taken the maximum element and minimum element, 5 minus 3. So they have subtracted that one, and then they created, after they got the subtracted value, then they created the new array. So that's why I'm saying creation of new array doesn't matter here, because we can try to find out some other ways to reduce that range. But the problem is here the length of original array. That length only we need to iterate every time. The maximum we need to iterate that array. So that's why the complexity, time complexity for this type of algorithms are generally, they say that n plus k or n, where they ignore the k part. So they say that it's n only. So that's why they say that for the count sort, it goes into the linear time. Okay, guys. So let's see very quickly code also. Okay, so Likit is saying, what if all elements in array are same of length 2 to the power 31? Then we have to consider J loop 2, right? What if in all element in array are same of length 2 to the power 31? So you mean the value of that array, value of each element in the array is 2 to the power 31. That much big, right? Value is there. So yes, in that scenarios, k will also matter, and in that scenario, yes, in that scenario, k will also matter. Definitely. That's why in the complexity they say n plus k, whichever is maximum there. In that case, yes, n plus k will be there, and k would be the, so again one loop only, right? Again you can see it's a while, one loop. In one loop we are doing. Correct? Yes, here I is k. That's right. Asking about j, okay. So in that case, if you are asking about j, let me read your question again. So what if all elements in array are same of length 2 to the power 31? Okay, then we have to consider j loop 2. If you see j, I'm referring it with n here. The j iteration, I'm referring it with n. Whatever the length of arrays, whatever the length of original array is, that is j. That is n. I'm referring that to n. Okay, and I'm referring k to I here. Okay, so that's why I was saying most of the scenarios, most of the time, we have to take care of the jth part, right? Because there could be 2 to the power 31 elements in that array, and that could be the problematic. But if we're talking about the I, so right now in our scenario, in our example, we have taken I as a max element in that array, and that max element could be anything, right? That could also be 2 to the power 31. That the biggest number one place can be stored. That much information we can store in that one, and we need to create that much array, right? So Likit is saying J is the count of element in array. Count of element. Yes, J is the count of element in the array. That's right. Count of element in the array. That's what the n is also. The count of element in that array. Okay. So guys, let's quickly see our code. How this is working in code also. Okay. Whatever we have explained, let's look into the code also quickly. Okay. So you can see here, guys. So first thing what we did from our given array, we have taken the max element. Okay. From our array, we have taken the max element. Then we quickly created the new array. You can see quickly created the new array with the max element plus 1. And that's what we were doing here also, right? 0, 1, 2, 3, 4, 5. We have quickly created all the arrays element and fill it as a 0. All the indexes right now, all the indexes element are 0 here. So right now empty array will be created where all the indexes will have 0 values. Correct? Then next thing what we did, we created the count of those elements which exist in the original array. You can see how we did that. We have taken the given array dot length. So this is first loop. You can see this is the first loop which we are going to run. Correct? This is the first loop which we are going to run. Now you can see we have added all the elements inside this array. You can see wherever the element is exists, do the plus 1. If element already exists, like do the plus 1. Otherwise, if it is coming first time, then take it as a take it as a 1 value there. You can see frequency is an array, and we are keeping values at the index position. Everyone understood this line? Let me know in the chat. Everyone understood what is happening in the line number 7? That's important. Yes, line number 7. Everyone understood line number 7? What is happening there? So see, Joseph, what is happening in the line number 7? This is our frequency array you can consider. And it has, okay, let me, I think here it will be better, right? Yeah. So this is our frequency array, which has all the indexes 0, 1, 2, 3, 4, 5. Earlier, all the values are 0, 0, 0. What is happening in this line? Frequency given array I. So like, what is the first values in the given array? Which is 1. So go for the 1 index. What is happening here? Go for the 1 index and do the plus 1 there. Do the plus 1 there. So already these are zeros here. So go to the 1 index and do the plus 1. So here it will be 1 at the first index. Again I loop will work. Next value of this original array will come, which is 4. Go for the 4th index, do the plus 1 there. It will be 1 here. Again, go for 2, same goes for 3. Go for 2, do 1 here. Go for 3, do 1 here. Right? And then go for 1. Again, go for 1 and do plus 1. So now this 1 will become 2. Now this 1 will become 2. Understood, Joseph? Okay. So that's what actually happening in the line number 7. Now let's move. So now we have created the whole array now. Now we have created this whole array. This one. Now we have created this whole array with the values. Now we need to iterate into, we need to create, we have taken 2 variables. You can see let I and 0. We have taken 2 variables. And then we are only taking the 1 loop here. So you guys can see that first we have ran this one, and then we are going for this loop. Second loop is going to be I less than equal to max element. That's one. So we can say if the given array length is n, if given array length is n, so first time we have ran this loop, and next time we are going for this 5, which I am taking as a k here. So that's why the whole iteration will be taking n plus k. And n would be the more would be we will be considering here n. This would be the bigger loop we are considering here, not the kth one. Okay. Now you can see the same thing when I less than equal to max element, and then again we are checking in the frequency array, it should be greater than 0. Then in the given array, in the same array we are using, we have not while I was explaining, I have taken the new array result, but right now in the same array, given array, I'm just updating the jth values. At the 0th index, I will keep the 1, then frequency minus minus, then j plus plus, I plus. And at the end, we are just returning back the given array. Okay, everyone understood this line? Line number 14 to 23. Let me know in the chat. Whatever we did in this notes, here, whatever we did in this notes, this side, this part, that similar thing is written in the code. Understood, guys? Similar thing is written here. Everyone understood? Okay, now very quickly understood how they have done in the slides. How they have done in the slides. Okay. So time complexity would be n plus k there, Joseph. And for running the main loop, which is this one, and k for running the max element loop. This k for running this loop. So the time complexity will be n plus k, where we will ignore the k, we'll only take the n. So that's why the linear complexity, we say it's there. Okay. And for space complexity, we can say we have created a new array. This whole array would be the space complexity there. I think for space complexity, it would be k only, because you can see the whole array we have created. This will come. Let me check the space complexity here very quickly. But I think the space complexity would be the size of this array which we have created newly. Earlier, I think we have not created anything new here. Let me check. Rather than that array, we have not created anything new here. We are just simply using some of the variables, then just simply updating the existing array. So I think this would be the space complexity, the extra space complexity. And I have to check how we represent this array space complexity. Let me check very quickly, guys. Or let me see in the slides if they have mentioned the space complexity. Yeah. Let me check in the slides. Yeah, so space complexity is O of k. That's what I'm saying. The k is the size of that the range or the maximum element. Okay, so let's quickly understood. See, guys, in the slides they have done little bit different. So let's see that how they have done in the slides, which was little. See, I find it little bit difficult to understand, but yeah, I will try to explain you how they have done in the slide. And then you guys tell me which one was easy. So 1, 4, 2, 3, 1, 1, 5. Okay. Let me come back. You guys can able to see my screen, right? No, not n, not n. K. The space complexity will be k. We are considering the new array as a k, right? So that's why the space complexity will be k. Okay, guys. So let's see how they have done in the slides. So see, first they have first they have find it out the max element. Max element is 5. Then they have find it out the min element, which is 1 here. Then they calculated the range, and they are saying range is max minus min plus 1. Guys, for everyone, I'm just explaining one more way to solve this problem, which they have mentioned in the slides. Okay, I'm just trying to explain one more way. So you can see here 5 minus 1, 4 plus 1 is equal to 5. Again, they have created the same array for this. Let me check also very quickly if I'm missing anything. Yes, max element minus element plus 1, and then they created the range array. Yeah. So then they created the similar for the same range. They have created the array. So let's create the array here. 0, 1, 2, 3, 4. I think 4 element will be here, right? 0. Yeah. The length is 5. Correct? Length is 5. Now see, from here, now the logic will start changing. From here, now the logic will start changing, because in the earlier problem, what we were trying to see, we were trying to find it out all the indexes where the element exists. But you can see now, 5, there is no index. For the element 5, there is no index. Right, guys? So from here, now the logic will change. So you know how they are keeping the frequency here? How they are keeping the frequency here? What they are doing, they are trying to fetch the element and subtract it from the main element. So like see, let's take the first element 1. We are just simply running the loop on this array. Okay guys, running the loop on this array. So first element is 1. So what they are doing, array of 1 minus main element. So what will happen? We'll get 1 minus 1 is equal to 0. So now you can say this 0 will represent the element 1. Now this 0 will represent the element 1. And then we will do 1 here. That's simply similar thing. Frequency plus 1 here. Okay. Now for 4, same logic. 4 minus 1. 4 minus 1 is equal to 3. Then at the 3 we'll keep the 1. Now this 3 will represent 4. Same goes for 2. This 2 will now represent what? 2 minus 1 is equal to 1. Now this 2 will represent 3. This 1 will represent now 2. And this 4 will represent 5. And then in the 0 we will get 3 because there is 1 3 times. Understood guys? How they have achieved this? They are just subtracting from the main element, and that many indexes they are trying to create it here, and then on those indexes they are trying to keep it like that. Understood guys? I think now this, see, let's see if we, I think this is little bit reducing our array of k size. Earlier k size was greater, but let's see, let's take another example, which is 2 4 5 6. If this is our array, and if we need to follow the same thing, you can say 6 minus 2 is equal to 4. So the 4 loop will be there, 4 indexes will be there, which will be like 0 1 2 3, right? 4 indexes will be there. Now 0 will be representing which one? 0 will be representing first element minus main element, which is 2. 2 minus 2 0. Now this 0 will be representing this 2, and we'll keep it 1. This 1 will be representing, I think, 4. Wait, let's check. 4 minus 2 is equal to 2. No, I think 2 will be representing here. Let's see, is it the same logic working here or not? 4 minus 2 is equal to 2. So 2 will be representing 4 here. Let me write it also. 0 representing 2. 2 index is representing 4. Let's look for a 6. Hey, what will happen for 6? 6 minus 2 is equal to 4. What will happen here for 6? Are we missing anything wrong? 1, 2, 3, 4, right? What will happen with this condition, right? I think we are good for 5 minus 2 is equal to 3, right? What will happen with the 6 minus 2 is equal to 4? Yeah. See, I think we got some problem here, right? That's what they are trying to do here. See, max element minus min element plus 1, right? And then they are trying to create that array range plus 1 range, right? Oh, sorry, I missed one thing. Sit, plus 1 was also there. I think you guys. Oh yeah. Oh yeah. That's what I missed that one. Yeah, then it will work. You can see plus 1 will be here, and then it would be 5, and then would we get the 4. You can see now the 5, but now the size of k is still less. If we talk about the previous approach, we must be creating the 7 indexes here, 5 6 7, but in this approach they are just reducing the size of k. Now you can see 1 will be here, and 0 will be here, and I think for 3 1 will be here. That's how they are doing it, guys. That's how they're trying to create the frequency. Now let's see, after creating the frequency array, what they are doing, what logic they are following. Okay, I was just trying to show you how the frequency array they are creating. Okay, now let's see, once our frequency array is created, what next thing they are doing. Okay, so this is our frequency array which they have created in this way. Okay, first let me know, everyone understood this way, how they have created this? Everyone understood? Yeah, let's quickly see what the next thing they are doing. Okay, so the next thing what they are doing, let me erase all these things also. So what is the next thing they are doing, guys? They are trying to add these indexes. They are trying to add these indexes. So like this will be looked like this: 3, because at the 0th index, 3 plus 1 would be 4, 4 plus 1 would be 5, 5 plus 1 would be 6, 6 plus 1 would be 7. You know, that's what they did in the next step. That's what they did in the next step. This was the step 1. This was the step 2. And you know why they did this? Based on now these values, they will be looking for the indexes here. Indexes for original array. Let me go further. Now what they are doing, they are now trying to go for the, again, they are running a loop on this array, the final array. You can see. Let me also quickly check the code, what they are doing next. Yeah, so you can see here till now they have taken the frequency. This is the step 1. This is the step 2, where they are just adding all the frequencies. Frequency sum is there. Now next thing what they are doing, they have created the new array, result array, with the same length given array. In our case, we have not created the result array, but they have created the, and but yeah, array is same. You do not need to create it. You can work in the original array also. That's fine. Yeah, so in the result array, trying to subtract the frequency, -1 is equal to this one. Correct. Okay, let me show you, let me tell you what they are trying to do it here, guys. So they tried what? In from this array, from the sum array, they have taken one value, which is 3. One minute, guys. Yes, given array -1. Yes. Okay, so what they are saying, what they are trying to do is, guys, take the first element from this array, which is 1, right? Which is 1. So now 1 result minus, again similar way as we were calculating the frequency for that, because we need to find the index, right? We need to find the index for element 1. So how we will find the index for element 1, which would be our original element, which will be main array. How we were doing the earlier, main array index I minus min element. That's how we calculated the index, right? Like 1 minus 1 is equal to 0. That's how we got this. For 4, 4 minus 1 is equal to 3. That's how we got this index, right? Similar way. Try to first find it out the index for the first element. So index for 1 would be 0. 1 minus 1 would be 0. And now try to fetch this 0th index value from the frequency sum. From the frequency sum. From the frequency sum, try to find out the value for that. So frequency 0 will be 2, and then they are doing 2 minus 1, which would be 1 here, and they're trying to keep this 1. You can see that's what they're trying to do, guys. In the given array, -1 minimum element, and then again -1 after fetching it from the frequency. After fetching it from the frequency, they are again subtracting it, and then they are getting the, then they are assigning that value to the result array at that index. So somehow they got the index, and the result array in the new array at the 1 index, they will assign this value 1. So see, let me write this code. I think this will be confusing for everyone. I also got a little bit confused there, but let me write it. Then I think this will be better. What they're trying to do there, yeah. So see, first we find it out the element, which would be main array, ith index minus main element. See, with this way, we will find it out our element index in frequency array, correct? And then they are doing -1 here, and after that they are adding it as a result array index and the value from the main array. Value from the main array. This is the line which they are running. So how? Now let's calculate it. So main array is 1. If we are taking the first element 1, minus min element is 1. Okay, and this is taking it from the frequency array. So 1 minus 1, frequency minus 1. This is the minus 1 they are assigning. And then result. This is the result array. Then 1 minus 1 is 0, which is 3. 3 minus 1 would be 2. Right? So in the result, is second index, keep the value 1. So in the result, which is our final array, like this, 0, 1, 2, 3, 4, 5, 2, 3, 4, 5. I think one more will be there. At the 0 index, keep the 1. Next, go for next value, which is 4. So 4 minus main element 1. In frequency array, it would be frequency 3. A frequency 3, if we see 0, 1, 2, 3, it would be 6. So 6 minus 1 is equal to 5. At 5th index, keep the value 4. So 0, 1, 2, 3, 4, 5. Keep the value 4 is at this place. Similarly, you will go that, let's check for 2. So 2 minus 1 would be 1. This is the index in the frequency array. Index value is 4. So 4 minus 1 is equal to 3. At the third index, keep this value. So 0, 1, 2, 3, keep the value 2. Similar way, you will got the 3 at the fourth index, 5 at the sixth index, and 1 here, 1 here. Because you are reducing also the frequency like that. So that's what they did in the that's what they did in the slides, guys. I think this part was a little bit complex to understand. Otherwise, all were easy. So once you understood this part, so I think you have understood the second scenario also. I think this part would be a little bit confusing. So let me first check in the chat. Did you guys understood this part or not? Or you want me to explain it again? Is it is it minus min or minus 1 to achieve array indexing? And by chance, our min is also 1. Yes, it's getting. Yeah, I think that part is, that's why actually I left it. I left this way and I tried to go with this easy way. Definitely in this way, our array size is increasing. You can see the size of k is increasing. But yes, this was very easy way to calculate the same thing. But yes, in this scenario, I think size of k is very less. They are just taking the range which is between these two. And then they were, after taking the range, they are just trying to add the frequency sum. After adding it, they are just saying that whatever the value is here, subtract it 1 into that, and that would be the index for element. See, it's very easy. See, if you got this, let me write it again. This one, the frequency array, which was 3, 4, 5, 6, 7. So what they are saying, guys, in this array, 0, 1, 2, 3, 4. This is the array. So now what they are saying, whatever values you are taking, these values are nothing. These are the indexes for these indexes. These are the indexes in the new array for the values, whatever values you are going to take. So see, these all these indexes are related, right? 0 was referring to one element, element 1. 1 was referring to, I think one was referring to which element? Let's see. It would be 1 plus 1, 2. Yeah. So it was referring to 2. 2 was referring to 3. 3 was referring to 4. And 4 was referring to 5. Correct? That was the array. So that's what they are saying. This would be the first index in the new array, in the result array, we have array, right? 0, 1, 2, 3, 4, 5, 6, 7, right? In this way, we have the array. Till 6, I think we have array, right? Till 6. So they're saying this would be the array's location for this element in the new array. We just need to subtract it. So see, 4 minus 1 is equal to 3. So this will be the position for 2. Same goes for 3 also. So 3 minus 2 would be 3 minus 1. 5 minus 1 would be 4, which would be the value for 3. So 3 will come here. Same goes for 4, same goes for 5. But at the case of this, where the 1 is coming, we have to reduce the frequency. We have reduced this frequency. So it would be 3, then 2, then 1. So that's why first index would be a 2, second index would be 1, and third index would be 0 for that. That's what the logic is written here. This is the logic which I explained you in this way. Frequency array, main array minus min element for finding out this value 0, 1, 2, 3, 4. This array, this value we will only find it through this main array minus main element. Then find it out that index value in the frequency, which would be 4, 5, 6, 7. Then subtract it into 1, and that would be the index in result array. And that's what we did it here. Okay, guys. Yeah, this is the code. Let me show you the code. This is the code, guys. You can see. This was the line which you guys are seeing a little bit complicated. Other than that, everything looks good. These are the lines only which you guys are seeing a little bit difficult. But I tried to explain it in easy way. In the frequency array, you can see in the frequency array, first they are trying to find it out that index. And that index we are only getting through the given array I minus main element. You can see while creating the frequency, we were also using the same logic, given array a minus main element. And once we find it out that index in the frequency array, we find it out the value. That value could be 3, that value could be 4, that value could be 5. Any values could be that. And then that would be the index for our new array after subtracting minus 1. And then at that index, we are keeping that element. Then we are reducing our frequency to minus minus. Okay, guys? So that's the only line. So whichever way you find it easy, you guys can follow this one, or might be this earlier one which we have talked about. So I will put both code here. Let me put both code here. Let me write the bucket 2 also. Bucket2.js. Let me paste this code there also. You guys can do the indexing later. I will push both codes, okay? Okay, let me correct the indexing little bit quickly. So this looks good. Okay, so here they are doing the sum. Okay. Then they have created the new result array, which is not needed, I believe. And then see why they are doing that, I'm not sure. And after creating new array, they're again assigning in given array. We can use the same array, right? But that's fine. Yeah, let me commit these changes. And I think I could take the new branch, it is stat, which would be 1 minute, get st. Yeah, so I get stat didn't work. Get DSLO, right? I'm in the correct folder, right? Yes. Oh, we need to add these files. Okay, so that's fine. Git checkout minus v day 5. I'm creating a new branch as a day 5. Let's post this branch. Oh, I missed the key in the git. Push the branch. So now let's push the changes also. Git add, git status, git commit, and git sort. Sorry, it was count sort, right? I've taken the wrong name actually. It was count sort, not bucket sort. Yeah, it was count 2 sort, yeah. Rename. Press count to. Yeah, yeah. Let's commit it. Get okay. Get st. Git add. Git status. Yes. Git commit. Count sort. Yeah. Now the changes are available in the GitHub also. Yeah. Yours was easy to understand. Yeah, first one is that's why actually first one is easier to understand. But yeah, it is taking more space in the K side. But in this algorithm, I think we have understood that it is taking less space for K. Okay, so now guys, we can go for now break, and then we can come back for our next algorithm, which is going to be bucket sort. Okay, so let's go for the break, and then we can come back. So right now it's a 9:41 or 9:42. So we can come back at 9:57. Okay. Okay, guys. So we can come back at 9:57. Let's talk about the bucket sort then. Is everyone back? Great. So guys, let's jump into our next algorithm, which is bucket sort algorithms. So let me ask again, is everyone back? Or because I think I told 9:57. So might be some of people are still not joined. Yeah, I think Nilanjan, did you join Nilanjan? Because Nilanjan always asks for 15 minutes. Nishant is back, great. Joseph is back, great. I'm feeling little bit actually today, you know, something in my throat. We'll drink more water. Let's see if it stops. Okay, so now 1 more minute there. Back just now. Okay, Arad. So yes, I was just waiting for you, Arad, only. I told everyone that Arad and will back, then we will start. Welcome, welcome, Arad. Okay, I think now everyone will be back because it's 9:57. So let's try to understand the bucket sort algorithm. Let's try to understand this algorithm first with one analogy. Okay. So you guys might have observed like we have to like wash our clothes daily, right? We wash our clothes daily, but some people are consider we can consider some people are so lazy. So what they do, they just wash their clothes at the end of week, right? So you can say in 7 days now they have a lot of clothes, then their pants, their shirts, like their socks and everything else, right? For 7 days. Now they have not washed it. So what they generally do at the 7th day, they will do the washing, and then they will have pile of clothes which they have to fold it now, fold it and kept it in somewhere, right? So what generally they do, they will like wait for 7 days, and after 7 days you will see all the clothes are in front of us, and then we now we need to fold it and kept it in different places, right? It happens with everyone. It happens with me actually. I generally wash my old clothes at the end of week, and then all of clothes are at one place. I need to fold them and iron them, and then I need to put it in. Sometimes it happens in 2 weeks also. Now I have like a lot of clothes to iron it, and sometimes it's little bit like it's very boring task also. Nishant is saying its highest score is 1 month. Yeah, agree. So see, so what happened? What happened that one day when we decide to fold it and iron it? What happened in that day? In on that day, what we do first, we take out all of our shirts, we iron them, fold it, kept it at one place. Then we take all of our pants, fold it, kept it in one place. Then we go for socks, fold it everywhere and kept it. And same goes for other clothes also, like hanky and other clothes, right? And then we kept it at different piles. So now you can say we have now 5 different, we can say buckets here, right? First bucket is for shirts. Second bucket is for pants. Third bucket is for socks. Fourth bucket for other clothes. Okay, guys, are we good till now? Did you understood how we have divided our clothes in 4 different buckets? Understood, guys? This analogy you understood? That's the similar thing we do with the bucket sort algorithm also. We got a large range of data, and then we divide in some way. So we can divide some part of data in one bucket, rest part of data in another bucket, remaining part of data in another bucket, and then we can sort that bucket individually. Then we can sort that bucket individually. And after sorting it out all the bucket, we can combine all the bucket and we will get the final array. Like once we sorted out all of clothes, you just go to your almirah, right, or cupboard, right, you just put it all of your clothes at different places. It like what I mean to say here, after folding it out or after creating bucket, you just kept all of clothes in one place. That's your closet or cupboard or almirah. So that's what similar thing we do in the arrays also. Once we first we get all the unsorted arrays, a big range of unsorted arrays, and after that, what we will do? We will try some out some logic. So we can kept all some of the elements in one bucket, another bucket, third bucket, fourth bucket. Then we will sort these bucket individually, and after sorting these bucket individually, we will just combine them because all of buckets are already sorted. So once now we have to combine it, and after combining it, we will get the sorted array. Can you guys relate it little bit with the analogy which I tried? But do these days, yes, Ekta. That's how they will come in the same bucket. They have to have similar patterns. That's how. See, the Ekta was asking, do these data in the same bucket have similar pattern? Yes. All the certs has to come at one place. Just relate it with the close analogy. All the certs has come into one bucket. It means all the certs have similar patterns because they are certs. So it means the similar thing, all the data which relate to one pattern has to go into one bucket. Which relate to one pattern has to go into one bucket. Which relates to another pattern, it will go into another bucket, or it will create a new bucket, right? So that's how guys the bucket sort algorithm works. Okay, whatever we said, let's try to understand with the see. There are some of the constraint I told you, right? These all sorting algorithms comes with the flavor, right? And I think I will give you one more example. I have seen one more example of this, like in the real time also, when we have like millions of data which we want to sort it, but we do not have proper memory. We do not have proper memory in our system, and when we want to sort the millions of data, so what we do, we try to fetch some of the data from there and kept them in small buckets, because these small buckets we have to decide. These buckets we have to decide. So in our system, which has less memory, we'll create small buckets, and then small data which we'll take from the millions of them and put it in the clothes, put it in the buckets, and then we'll sort it up, combine them, kept it at one place. Then again we'll take the remaining data from there, kept it in the bucket, add them, and then combine it with the previous one. So in some scenarios I was reading in the internet, they were giving in this way they are using the bucket sort. But yes, bucket sort could be used in many places. Okay, right? Like in one of the scenarios, most of the places bucket sort says that we should have uniform data. We should have uniform data within a range. Like there could be one range, like 1 to 10. You have to sort it, and all the data should be uniform. If your data is uniform, I will tell you what is uniform. If your data is uniform and if you have any predefined range, if these are the two conditions, you could sort your array in linear time. You could sort this array in linear time. Okay, let me first show you how. Let's take one example very quickly. Let's create a new page. I hope you guys are able to see my screen. Let me know in the chat you guys are able to see my screen or not. Okay, 1 minute. Let me just turn off the fan, guys. Okay. Uh-oh. Yeah. So this time I'll try to write bucket. Oh, nice. I'm also happy when this marker is working properly. Okay, so now see, we'll take one example. Let's see if they have taken it this example in the example here. Oh no, they have not taken it an example. Okay, so see, sometimes we will have the questions like this. We have the range like 0.1 to 0.13. This is the range they are giving for our arrays element. So like, what is the meaning of range? So all the element will be between them. So like the element would be 0.1, 0.2, 0.3, 0.4, right? Or 0.5, right? Let's take all the uniform. Do not take this one. Let's take 0.7, right? 0.8, right? This is our array, guys. Okay. Now we already sorted. Oh, mistakenly, I have taken all the elements which are already sorted here. Somehow we need to take this array in unsorted way, right? So like 0.8 could come first, then 0.1 could come, then 0.4 could come, 0.3 could come, 0.2 could come, or something like that. 0.9 could come. This is an unsorted array, and you can see we are taking the range between 0.1 to 0.9. That's the range. Now we need to sort this array. Now, and we got that we have the 10 buckets. We'll also get the buckets number. So we'll get the 10 buckets. Correct? So now what we'll do, we'll first create these 10 buckets here. So this could be first bucket. We can take the indexes like 0, 1, second, this is third bucket, this is fourth bucket, this is fifth bucket, 6, 7, 8, and 9. These are buckets. Okay, guys? These are different buckets which we got. 10 buckets somebody has provided us. In these buckets, we can kept our element. Now, what we need to what we need to do, guys, we need to somehow make the pattern here so we can assign these values to these buckets. We need to somehow make some pattern here so we can assign these values to buckets. And when I was saying about the uniform, you can say there are all the elements are unique. All the elements are unique, and there is like, so once wait for that uniform, but let's try to understand. We need to create some pattern here so we can simply assign these values here. So what could be the pattern here? So like the pattern which we are going to follow here would be, take the array's element and multiply by 10. Take the element from the array like 0.8 and multiply by bucket length, which is 10. What we will get? 8. So now assign this 0.8 to the bucket number 8. Now 0.8 will be assigned here. Similar way, 0.1 will be assigned here. We'll multiply 0.1 multiply 10, we'll get 1 here. Now this 0.1 will be assigned here. 0.4 will be assigned here. 0.4. Now I can say 0.3 will be assigned here. 0.2 will be assigned here. 0.9 will be assigned here. And after that, once you assign all the element, just combine all the element. Just combine all the element in the same way as the bucket is. So once you will combine, first 0 index will come, then 1 index will come. It means 0.1 will come, then 0.2 will come, 0.3 will come, 0.4 will come, 0.8 will come, 0.9 will come. That's how, guys, this is the, now you can see we got the sorted array. And you can see the this calculation part, it is not taking any time. This calculation part is not taking any time. Just the time which is taking here, just the assigning value. After creating the buckets, like creation of bucket, and then assigning the values. So you can see we are just iterating into this one, and then after that creating this bucket. So bucket side, which could be k. So you can see n, first time iterating into this one, and then the next time after like assigning the values into this, we are just trying to read this array also. So now the time complexity is here n plus k. And guys, Right now you can see we have taken all the unique values, but there could be, this is the first thing. First you have to understand this part, how this happened. Then we'll see some more scenarios here. This is not done, guys. This is not done. I am telling you, this is the best case. Everyone, this is the best case which I explained here. This is the best case when we got all the elements as a uniform. But there could be the elements like this. If I increase my range from 0.12 to like 1 point or 0 point like 55, if I increase this range to this one, then you can see, well, we can also get 0.11 or 0.41, 0.31. Now the same logic will, in the same logic from 41, what we have to do, 0.41 multiply by 10, we'll get 4.1, and we'll take the lower bound. Lower or floor, math.floor, simple math.floor, which will again give us 4. Now you can see after 0.4, there will be one more element, which would be 0.41. Same, there could be 0.45 also. This 4 will also come here. This is the worst scenario, guys. This is the worst scenario. And in this scenario, what this says in the bucket sort, you need to internally sort this array. I told you, right? Take each bucket and internally sort these arrays and then combine it. So that's what see, this is all the bucket sort algorithm is. You have to first find out the logic, so you can assign those all the elements to bucket. That's the logic which I'm talking about here. This is the logic which they are talking about here. Multiply it by buckets, then take the lower value or the mat.floor. After that, after assigning it, because at the same bucket, multiple elements could also come. And this is the worst scenario where the multiple elements are coming. This is not the uniform array, I could say here. Because now you can see in the same place, multiple elements are coming. Once this scenario is coming, so you need to internally sort this array, and you can internally sort this array with any of the existing algorithms like quick sort, insertion sort, selection sort, anything. Or you could even try again the bucket sort for sorting this particular part. You can again take 0.4, 0.41, 0.45 as a next array, and then you can apply again the bucket sort, like try to find out some logic. So these all three elements could be assigned to three different buckets. Okay, so in the worst scenario, guys, the time complexity for the bucket sort is n square, because this particular sorting could take insertion sort, or this could take like quick sort or anything. So in those scenarios, it will be maximum, it will go n square. But in the best scenario, this algorithm can give us n plus k time complexity, because in the best scenario we are going to get one element in all the buckets, and then we will get the n plus k time complexity. But in the worst scenario, in one bucket there could be multiple element can come, and then we have to sort it. While sorting this algorithm, we will also try to use the best possibility which could give us the best like n. Because if you remember, in some of the scenarios in insertion sort, selection sort, also we could get time complexity as n also. So we'll try to keep our, because this is we are keeping the elements. We need to keep these elements in some ways, so we can quickly find it out, quickly sort this internal array. And then, but yeah, in the worst scenario, people says that this could take n square. But in the best scenario, it can go for n plus k. Let me know in the chat what are the. I know there would be some of the things which could be problematic here, but let's see. Like it is saying it's only for decimal, which are of 1%. No, it's not only for decimal. That's not right. We can take the numbers also. Like we can take 21 to 55. The range could be 22, 23, 25, 26, 27. Now this logic will change. Now Likit, this logic will change. Now our bucket is 5 here, so we will create 0, 1, 2, 3, 4. See, they so first thing everyone, the thing which they are telling here is not fixed. It's not like that every time for getting the bucket value you need to do these things only. You could change it also, but the main concept is here you will get one range. You should get one range, and in that range, if your arrays elements are uniform distributed, so try to create the and take some buckets. These buckets are like these buckets are nothing, it's an array. So take another array and then try to assign these values in that array in a way. So you guys, if you'll see, this is similar to the count sort only. In count sort, we were trying to keep the frequencies, right, for the of the element, but here we are directly trying to assign the values there in the array index. You can see these are arrays index only. B0, B1, B2, these are arrays index. And then we are simply trying to insert these values there. And there could be multiple values also, 0 0.4, 0. In similar way, you can assign these values also, 22, 23, 25. They have given one example for these also. I will show you. In the slide, they have given the example for this also. I'm not sure they have given it here or not. Yeah, I think they have given, see. Yeah, you can see the example. They are also using the bucket sort for the integers numbers also. And see the similar thing. I think different logic they have taken. Math.max. First they have taken the max, then min, then again like for finding out the number of buckets, they are doing like max element slash base. So would be like taking 29 divided by 2. Yeah. So they have taken the least digit. So 2, 3, 1, 3, 2, 4. That's what. Okay. What they did? Let me explain you. What they did, guys. They have taken this example 22, 23, 22. I think this is the worst case. So they are taking the first digit here. 2, 2, 2, 2, 2. And all these n will be assigned here. 22, 23, 25, 26, 27. And then we have to sort this and then we can return the result. That's what they are doing. So what they are doing, 22 divide by 10. That's what they did. And they have taken the 2 here. Understood, Likit? I think some Ruby found this complex bucket sort. It's also look complex to you? I think these both algo, count sort and bucket sort, are very easy. It's just understanding the logic part. And I think a lot of places I have seen with the large data, people are using these bucket sorts only. How we will sort inside the two? Simply use any of the sorting algorithms inside that index. So see, Lakit, this is the 5 index. If we consider we got the 5 bucket only, if we have taken the 5 bucket, you can see 0, 1, 2, 3, 4. This is the 4th index we got, and at the second index we got 5 elements, right? So now we will iterate it. Now we'll iterate for loop here. I is equal to 0, I less than 5, I plus plus. This will be the 5, right? Now I is equal to 0, nothing to do here because there is no element, nothing to do. I is equal to 1, nothing to do. I is equal to 2, yes, we got one array of elements. Again, 22, 23, 25, 26, 27. Now you need to sort this. Already this is sorted right now. Now you need to sort it. You can again use the bucket sort, or you can use any other sort, quick sort, insertion sort, anything you can use it here. And then once you will got it, you will just combine that array. See, this is bucket sort is best when you have large data of range. So you can keep half of element here in this index half of element, because see, in one index, in one array, you cannot keep like if there are 2 to the power 34 or more than 2 to the power 68 element, so you cannot keep all those elements at one place. So you have to divide those elements. So 2 gigabyte 34, you can kept it here. In remaining 2 gigabyte 34, you can kept it here. And then you can do the sorting for 2 gigabyte 34 only with merge sort, quick sort, which is the best. Whatever the algo is best, you can use for that. So bucket sorter, advanced. These algorithms are the advanced sorting algorithms, right? Which are, so you most of the scenarios you have to use the comparison based algorithm because they give you the best time complexities, right? And that's why they are little bit harder to understand also. But if you got like little bit advanced scenarios where you have a lot of big data, on those you use some extra space. You can see here, right? We are using some extra space. Whenever we need extra space, it means we are going for like big range. Okay, let's see other questions. If we have multiple elements in single bucket, we will apply others. Yes, sir, that's right. N plus k explains, sir. So n is the n is the number for the array's element or the range which we got, and k is the, we can say here, k is the bucket size. The k is the bucket size, the element which we are taking in the buckets. So that's why n plus k, because first time we need to iterate our arrays element to keep these informations into n is equal to k. No. N is not equal to k. Look it. N is the elements in the arrays, and k we can say that the the size of our buckets. How many buckets are, how many buckets we are taking. And in some scenarios we can say this k is going to be great. In the worst scenario, the internal sorting algorithm will take more complexity. So in those scenarios, the k will be ignored and another n will come. And that will make our equation to n square. That's why I'm saying in the worst scenario it is taking n square, because I'm saying in the sorting algorithm we'll try to go for the best sorting algorithm which is going to be give us linear time. That's why in those scenarios I'm considering my k, in that scenario k will be ignored, another n will come. Okay, in the worst scenarios. Can you please explain the case where n is the value of max one? No, n is the value of maximum elements. N is the value of maximum. N is the value of number of elements in the array. Number of elements in the array, because we need to iterate those array to finding out this logic. This logic you need to run on the array, right? On this array. So this is the n. That's why the first complexity is n. That much time we are taking. After that, I am saying for the k, there could be two scenarios. First scenario, when we have uniform everything. When we have everything uniform. So we just need to traverse this whole bucket. That's the k. That's why n plus k. But in some scenarios, if any of the index has larger values like this, 0.4, 0.4.1, 0.455. Now we need to apply another sorting algorithm here. Which will take again n time. Whatever elements are there, see, in generally insertion sort on those take n square. But I am saying that we are going to take the best one, which is going to be n log n or n. So in those scenarios, k will be ignored, the another n will come here, and which will make our which will make our complexity to n square. Okay, that's the last scenarios. Okay, understood everyone? Let's see quickly the code also. Let's see quickly the code for this, for the bucket sort. Okay. Okay, so now we can see we are passing two things. This is our array 0.29, 0.34, 0.19, 0.39, 0.21, 0.41. And we are saying number of bucket which we are going to use is 10. Okay, guys, number of bucket which we are going to use is 10. We have passed both things into our array, which is bucket sort. You guys are able to see my screen, right? Oh, great. How do we decide number of buckets? So see, we can provide manually also. Or there are some of the ways to calculate the number of buckets also. So right now I have showed you one way right here. In the logic, you can see number of bucket, how they are calculating. Like this, the maximum element divided by base minus minimum element divided by base plus 1. That's how they are creating the number of buckets. Okay, and I think mostly it depends on, I believe mostly it depends on like the range of data which we are taking. Mostly it depends on range of data which we are taking. So if in some scenarios we do not need to go for 10 buckets. In 5 buckets we can also solve the problem. So that's why the value of k is not like fixed. It's constant. It's going to differ based on use cases. Okay, so let's first by default, by default we can say it's most of the scenarios we have seen by default they are taking 10. And if you are like if any interviews they are asking about it, you can take the 10 there while explaining your logic. Okay, so let's understand their code. So what they did, guys? First they have created the bucket here, the new array. You can see number of buckets. So like bucket will be one, array will be there, and then each index they are creating another array. So let me show you what does it mean. Let me show you what does it mean. So first they have created one bucket array like this. Number of buckets are 10. So they are like writing like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 10 elements are there, right? One, two, three, 4, 5, 6, 7, 8. Now, yeah, this is the first line. 1 minute. Yeah. Okay, this is the first line where we have created the new array. Now this is the next line. What they are doing is in each index of that array, they are creating one more arrays there. So what does it mean? For with each index, they are creating another array here, like this. Because I told you right, at each index, multiple element can be kept there. So that's why we are taking arrays here. So you can see now our bucket is ready to keep multiple elements. Now our buckets are ready. These are our buckets. These all buckets are ready to keep kept multiple elements, not one element only. Okay. Now let's see in the next line. Yeah. Now let's see next line. Now in the next line, what they are doing? Yeah, the logic part. The first loop. The first loop is running. Given array dot length, math dot floor, 10 multiply by given array. The same logic which I explained here. Math dot floor, 10 multiply by array of element. So in our case, the first element was 0.29. First element was 0.29. So multiply by 10, it will become 2.9, and mat.floor will give us 2. So at second index, at this index, we'll keep 2.9. Right? So you can see we are pushing it. You can see given array. Where is that? Yeah. No, not this. Yeah. Bucket index dot push. That's what we are doing. Given array I. That element we are pushing it at the index dot push. Why we are using push? Because this is an array. Correct? Let's insert another elements also. 0.34. So it will be inserted at third position. So 0.34. Sorry, they are inserting 0.29, not 2.9. 1 minute, guys. Because they are inserting the original element. So 0.29, 0.34. What is the next one? 0.19. So it will come here, 0.19 at this place. Right? Next is 0.39. Again, now next element in this array. After 0.34, 0.39. Okay. What is next? 0.21. After another element in this array, 0.29, 0.21. Okay, guys. You can see this is another array. Next 0.41. So this will be come at this place 0.4. So like look like this 0, 1, 2, 3, 4. Only these four places are used. Here 0.19. Here we have 0.29 and 0.21. And at the third position we have 0.34, 0.39. And here we have 0.4. That's the that's what we did here in this line. And let me show you in this bucket. Let me show you guys. Let me show you before sorting each bucket. You can see after that they are sorting also each bucket. They are simply using the sort. Whatever language internally, whatever language, whatever JavaScript language is using sorting, that's what will be utilized here. But you can create your own sorting also, and then provide like pass each arrays there. But let's see before sorting and after sorting how they look like. Let me run it. You can see guys. This is the before sorting each bucket. Before sorting each bucket, you can see zero index, there is nothing. So this is empty array. This is empty array. At this place, empty array is coming. Here, this is the array. Here, this is the array. Here, this is the array. And here, this is the array. And that's what you will see here. 0.9 as the first index, 0.29, 0.25, 21 is the second index, 0.34, 0.39 is the third index, same like that. And then we ran the bucket I dot sort, which has done this part. You can see now 0.21 and 0.29 got sorted. Earlier it was like this 0.29, 0.21. Now 0.21, 0.29, 0.31, everything is sorted. Now we just need to combine this array. We just need to combine this array. So that's what they are doing. I is equal to 0. I less the number of buckets. So number of buckets are I think 10. Yeah. So 9 times this loop will run. And then internally for each index, because from each index they have to fetch the element. So that's why bucket I dot length, whatever length for each index. Then in the given array, in the original array, they are just simply updating the original array index plus plus bucket ij. So like first time bucket 00, this element will come 0.19, right guys? Then this element will come second one. And you guys can see why the first array element is not coming, because of this condition bucket I dot length. Wherever bucket I dot length is greater than 0, only those elements will be coming here. This empty array we will not consider. This empty array we will not consider. We'll only consider wherever the bucket length is greater than 0. And in those scenarios 0.19 is here, 0.21, 0.29. Only these array will be iterated, and then finally we'll get our given array. 0.19, 0.21, 0.29, 0.34, 0.39, 0.4. Let me know guys, you guys face any problem with the coding part? I think that was easy, right? Code was very easy, guys, right? Yes, actually, these both actually, not the bucket only. Count sort is also very easy. Count sort and bucket sorts are both are very easy. Explaining, like in explaining also, or in the coding wise also, both are very easy. Let's see one more scenario they have given in the code. Let's see that code also, how they have done it. Okay. So this is the code which I have shared it. Let me push these changes. If I have not already, I think yeah, already pushed it. So let's another bucket 2 also, because they have given one more example for that. Bucket 2.js. Let's copy that code also. Let's quickly understand that code also. Right, this is the example they have given. Okay, can't copy paste it. Okay, yeah. Let's take this code also. Let's quickly understood this one also. Okay, let's see if any theoretically they are saying anything. So bucket sort is sorting technique where we divide the given arrays into buckets of element depending upon some property of data sets. Okay. Then separately sort all the buckets using different sorting algorithms or recursively calling the bucket sort on it. So that's what, guys. Right now you can see in the bucket sort, I was simply calling any other sorting algorithm which JavaScript is using, but we could again use the bucket sort only. We can again do the bucket sort for sorting the 29 and 21 also. We can try to do that also. And that place we can take the last digit 9 comma 1. Guys, for the 29 and 21, if we have to sort it, these two elements from the bucket sort, what we can do? We can take the last elements also, right? 9 comma 1, 9 comma 1 we can take. Complexity is still be same. Yes, complexity is still be same. And the another for these two elements will be n square. The worst scenario is always there. If it is not uniform, then worst scenario is still coming there. Okay, right? But yeah, the way I'm telling, I think 29 and 21 is there. So you can take the second digit, 9 and 1. Correct? Yes, that's right. Space complexity will definitely increase here. If you will again use the bucket sort, that's right. Space complexity will increase. I agree with that. Okay, so let's see quickly this one also. I think I already copied everything, right? Yeah, already copied everything. Let's quickly see this part of code also, guys. Oh, not this one. Oh yeah, this one, right? So what they are doing here, guys, they have tried, let me first do the indentation, which is not, they have done correctly. Okay. This is the same lines, okay. We can put it here. Then we can take this for loop inside it. First it belongs here. You're not taking the curly braces, but yeah, JavaScript is still fine with that. If you're not using curly braces and you're writing the next like one expression only, it will execute. But for multiple expression, it will not take it. You have to use the curly braces there. That's why wherever the one line expression is there, they're using without curly braces. Okay. That's the JavaScript properties, guys. Okay, let's see. So right now, guys, they have not provided the bucket. You can see in earlier problem, we were passing the number of buckets from our side. But in this scenario, they're not passing the number of buckets. We are going to calculate it internally. So let's see how they are calculating it. And right now, you can see they are providing the positive integers number. Let's see. So what they did for calculating the number of buckets, guys, they have taken the max element, main element. So see, the max element would be here 41, right? So the max element would be here the 41. Let's see the main element there. Main element would be 19, right, guys? Main element will be 19. Then what they did, they used this logic math.floor max element divided by base minus math.floor main element divided by base plus 1. So let's see max element divided by base. So base is 10, they have taken. So 10 divided by 41 divided by 10, it will give us 4. So this will give us 4, right, guys? And this will give us 1. So 4 minus 1 would be 3 plus 1 would be 4. Am I right, guys? Have I calculated number of bucket correctly? You guys tell me in the chat. It should be 4, right? Great. It should be 4. So let's see. Now they have created the array for 4 buckets only. So now you can see we are not taking 10 buckets here. We are just taking the 4 buckets. Okay. Similar thing. You can see similar thing again. We have just at each index we were taking the arrays here. Correct. And then at each index we are pushing the element. But see, you can see before doing that, starting from the main element, not from 0. So before that, they again, see, I think you remember the similar logic they were trying to implement min element in the count sort also. That's what I think they are trying to do here also. Before pushing it to the bucket, I think the logic which they are applying here, that's this is like earlier we were applying multiply by 10 and then take the floor value, but they are applying here to take the minimum value, subtract the take the array element, divide by 10, then take the minimum element and divide by 10 and then subtract it. So let's see this logic. 1 minute, guys. Let's take this array there quickly. We'll quickly see that. No problem. So 29, 34, 19 is there, 39 is there, 21 is there, 41 is there. Okay. How they have calculated number of bucket? Number of buckets, they use this formula. Take the maximum, divide by 10, minus take the minimum, divide by 10, and then plus 1. You can see 2, sorry, maximum was 41, sorry. So 4 minus 1 plus 1 is equal to 4. So these are 4 buckets we will create. So now 4 bucket looks like this: 0, 1, 2, 3. Correct? These are the 4 buckets, and we can say these are arrays. Right, guys? These are arrays. Now you know how they are inserting it elements here. For inserting the element, they are using this formula: mat.floor array element divide by 10 minus mat.floor minimum element divide by 10. That's what that this is the index. They will find it out. These indexes will be find it out, and then in this place we will keep that array of I. Let's see for the 29. For 29, so array I would be 29 divided by 10. It will give us 2. Minimum is 19. It will give us 1. Right, guys? So now index would be 1. So at the 1 position, at this position, we are going to keep the 29. Right? Let's look for 34. Let's look for 34. That was for 29, right? 29, let me write it so it will be better, right? Minus 19 divided by 10, which was 2 minus 1 is equal to 1. That was the position. Let's look for 34 quickly. So 34 divided by 10 minus 19 divided by 10. It would be 3 minus 1 will be 2. So there will be second position. 34 will be inserted here. I think 19 would be 0 because 1 minus 1 would be 0. 19 divided by 10, 19 divided by 10, it would be 1 minus 1 would be 0. So 19 will come here. Right? Let's look for 39. I think 39 will go for the second place only. I understood. Like you can see we are only taking the first element, and then why we are doing this min element to get our indexes, to get these values in the range of this 0 to 3. You can see that. I think we will get between that. Let's see, are we or not? So 39, 19 divided by 10. So 3 minus 1 would be 2. That's what I told you. 34, 39 will come here. Next is 21. 21 will go here. You guys already aware of it. So 29 will go there definitely. It will be 2 minus 1 would be 1. Then 41. You can see 41 divided by 10 minus 19 divided by 10. 4 minus 1 is equal to 3. And this it will come here. 41. Okay, guys. So that's how. See, I think this one is not. I think we can think about this one thing, guys. I think whenever we are using the maximum element minus minimum element, I think the next array which we are creating, it's always going to be less size. See, in the count sort also you guys have observed, right? In a count sort, you guys have also observed, we were taking the max element plus 1, max element plus 1, that much array. It was taking a lot of space. But whenever we are trying with max element minus min element, I think we see it makes sense also, right? If you will see, let's take any of the arrays example. Let's take any of the array example. Let's see, our range is like minimum element in our array is 2 and maximum element in that array is 6. So now how many elements would be there? 2. Let's take this. Why this way is better? Let's try to understand this. Like I'm considering in my array, my minimum is 2, max is 4. So my range is max is 6. So my range is 4. Right? So how many elements this array can have? And I'm saying all the unique elements. So 2, 3, 4, 5, 6. So the 5 element could come here. So that's why in the count array, if you guys remember, we were doing the 4 plus 1, and that much array we are creating. Right? That's that much array we were trying to create it. And if we say, like, if we want to say just the midding, like the between elements, or like the array will be between. No. I think this is correct, right? This is correct. These many elements could only be there, or the like these 4 elements could also be there. 2, 4, 5, 6, or 2, 5, 6. These 3 elements could be there. So all the conditions will be satisfied with 5 indexes. So if we consider 0, 1, 2, 3, 4, all the condition, all the elements, you can see 0 could be referring to 2, 1 would be referring to 3, 4, 2 will be referring to 4, 3 will be referring to 5, 4 will be referring to 6. So that's why, guys, I think max minus min plus 1 will cover all the elements from that array. That's why max minus min plus 1. Let's see any other example if you want to take. Let's say simple 1 and 5. It will be 4. How many possibilities are there for 1 or 5? Where the minimum could be 1 or maximum could be 5. How many possibilities are there? The maximum could be 1, 2, 3, 4, 5. So 4 plus 1 would be 5. You can see 5 element could be easily mapped. Or if there are 1, 3, 4, 5, still 4 elements are still possible inside the 5. Same goes for 1, 4, 5. So that's why I think the max minus min is best way to like optimize your space, or I think time complexity also, because now you need to create less array, and that's what, guys, we did it here also. You can see the number of bucket we are taking 4 minus 1 plus 1, max minus min plus 1. Right, guys? Max minus 1 plus 1. And that's how, and now while assigning these values, every time we were trying to subtract minus min element. Every time in each element, we are trying to subtract the min element. So we get the range of those indexes between these values, 0, 1 to 3. And then after we get this array, guys, what we did after we get this array, we again did the similar thing. We sorted it out. And then again, we assign the values from the array. Let's run this code very quickly. Let me run this code. Where is that? Yeah. So node bucket 2. 1 minute. It's in the sorting folder. 1 minute. Sorting bucket 2. But there. You see, before sorting, this looks like this because see, only the 4 array is there. Or you can see earlier scenario when we were taking the 10 bucket, those some of the spaces were being wasted. But in this scenario, our space is not getting wasted. And our loop also, you can see it will only run 4 times. Right? So you can see before bucket, it was look like this: 19, 29, 21, 34, 39, 41. And then we have sorted it out. It looks like this. And then at the end, we got our result. Everyone understood this code? Yes, sir. Yes, it would give max number of indices we need and save some space as well by not picking our starting index as 0. Yes, if you're talking about the max element minus min element, yes, that would work. What if we have the decimal mixed with integer? Yes, then it will create the problem. Lick it there. I think it is best for decimals or simple integers. If there is a mixed scenarios, it could create a problem there. Again, it goes to the earlier count sort problem, negative and positive. It goes to the same problem. It's best for unique. If there are unique elements, it's best. It will give you the linear time. Okay, Raj? So I think let's see if we have anything else in this. So yeah, so time complexity is will be O n plus k, number of buckets, and k is the complexity of sorting a bucket. They are same. And space complexity is same, whatever the n is the number of elements. Based on assumptions that data is uniformly distributed among the range. It's also a non-comparison based algorithm. We are using some properties. So probably divide the bucket, but if you use the same comparison based algorithm sort of bucket, still it will be partial comparison based algorithms. Yes. Because why it is partial? Because we are using some of the bucket features and then we are using the comparison base for sorting our individual bucket. So that's why it's partial comparison based algorithm. Let me see some other questions. Can you run this code with decimal? Okay, so let us say, is this the reason why we are not getting an empty array in between while printing the array after sorting the max management? Yes, sir. Yes, Ekta. Because now we are not taking the extra space. We are only taking 4 indexes, and in those 4 indexes only we are assigning all the elements. Okay. So Arad is saying, can you run this code with decimal? With decimal, this will create problem, right? Because we are dividing the base there, right? With decimal, Arad, we need to multiply it. With decimal, we have the code here, right? The first one, where we were multiplying it. No, this code will not work there. We have to change little bit change. We have to do little bit change here for working it with the decimal. And what would be those changes? I think the changes we have to do it here in the max element divided base. Rather than that, we might have to do here multiply divided base for this decimal. And then we have to take the floor. Yeah. Let's see. Let's see if you want to make this code to work for that. So let's see. So we have to do first here multiply. Okay. So now it will pass 0.41. We'll get 4 here. And 0.19 we'll get the 1 here. Okay, that's right. And then here, while calculating this, let's see. Given array multiply by 10. Yes. And then mat.floor minus. Yeah. Here also it will work. You just need to do multiply here and multiply here. Let's see. This is working or not. Let's pass the previous array. This one. Okay, let's try. So we can see 0.19, 0.29, 0.21, 0.34, 0.39, 0.41, and then we have sorted it out, and then we finally got our sorted array. Understood? Understood, Arad? What changes we did? Earlier we were dividing it because we were thinking our array was integer, right? Now we have converted into the decimal part. So guys, these algorithms were very easy, I would say that. And you just need to practice one time. And after that, I personally feel you do not need to practice it because in the and see, you need to remember the logic because you might use this logic in some ways. Some ways you need to create the arrays. In some of the problems we have seen, like Ekta was earlier saying, anagram problems or finding out the duplicate values. In those places, we can use some of the strategies from this from the count sort or from the bucket sort. Some places we can use the map also, like for counting the elements in array or duplicate values in the string. For these type of problem, we can do the map also, as map or simple objects also we can use. But with the array also we can achieve it, and we have seen some of the parts of this logic today. In the interviews, I have not seen anywhere they are asking about the count sort or like bucket sort or Radix sort. But yes, these type of scenarios we see when we have large range of data, and like a lot of data are there and we need to sort it. Mostly I think in the projects wherever we have when we are working with lot of like Amazon website or Netflix, because there are a lot of data got distributed at minutes or in seconds. On those scenarios we might see these type of advanced sorting algorithms people are using it. Okay, but yeah, in interview, personally, I have not seen it anywhere. Everywhere, people are asking about a quick sort, merge sort. So that's a really little bit difficult also to explain and understand. But these two algorithms are very easy. And tomorrow we'll do the Radix sort. That's also not very complex. It will also look like similar to these two only. And then we'll see what else we have in the next class. Okay, guys. So that's all from today. I hope you guys have found it interesting to understand the count and bucket sort. And I hope like the example of clothes where you guys will always remember while explaining the logic of bucket sort. And I hope you understood the code also. So I want you guys to first once practice it, like before looking, like without looking into the code. I want you guys to practice it in your system, and if you guys is stuck anywhere, this parts of code is already pushed, I think. Okay, some changes are here which I did for this. So let me, okay, I'm not pushing these changes which I did for multiplying. I think whole file is not there. Okay, let me push it. 1 minute, guys. Let me revert back the changes first, which I did for, yeah. Yeah, I think that was only the changes. But let me see if it's working or not. Yeah, it's working. Now let me push it very quickly. 1 minute, guys. These all changes will be available in the GitHub also with the branch day 5. Okay, we have not committed. Okay, 1 minute. Okay, 2. Yeah. Okay, I think in the next class it will be similar like that. And I think very soon our new topic we are going to start, which is linked list. That is going to be very interesting topic, and lot of interviews the people ask about the linked list. So we'll see there. And linked list is also very much interesting. You guys, I hope while I'm explaining to you guys, because in my college also, like my teacher has put a lot of pressure to understand the linked list. And in interviews also, people ask a lot of time about the linked list problem, linked list trees, these type problems people ask. So I think, yeah, very soon, I think after tomorrow's class, we might be going to start the linked list. And then there you guys will see the interesting things. These are, I think, whatever we discussed today and next class, just for knowledge. I would say that just to keep these things in knowledge. And because who knows, if you have any bad luck, somebody can ask. Somebody could have bad luck also, right? Somebody can ask there, tell me about the Radix sort or bucket sort, tell me about the count sort. So these are very easy things to explain. Tomorrow class is about Radix and count sort part 2. Yes, I think tomorrow would be Radix, and I have not seen the whole slides, but yeah, we'll see. Oh, time just flew. Oh, thank you, Ekta. is recursion uses in linked list? We'll go with the iteration way. We'll go with the iteration way first. But yeah, we can achieve some of the things in linked list with recursion also. Not tomorrow. I think class in Friday and Saturday. Recursion, in the like dynamic programming or in the backtracking, like while traversing trees or graph, recursion helps lot. Like you, like while doing the iteration with the simple while loop or for loop, you have to think too much. You have to think too much for traversing through the like iteration way, while loop or through the for loop. Mostly while loop people use while iterating in the trees or in the graphs. But recursion helps a lot there. Really, like you can quickly understand the things with recursion. We'll see if in our next classes if we have trees or anything. I'm not sure, but I've seen the linked list. There is one slide for linked list which they have shared in the content. So definitely we are going to talk about linked list. It's interesting. So that's all, guys, from today class. I got, I think, something in my throat. So I will see. I will also now rest it. And I want everyone in the, as I was telling in the earlier, when we started session, please start doing the problems in problems from lead code. If you want really all those classes which had happened to be useful for you guys, please start doing problems from the lead code. See, do not start problem with lead code. Start reading those interview experience. Everyone, start reading those interview experience, Slavis, career. You will automatically get the vibes that you have to practice these problems. And it's not difficult. People are practicing for 2 to 3 months or 4 months, and then they are cracking the interview for like Amazon, Google, or Microsoft. People are doing that. Some people are taking like lot longer time also, like 2 years also. It's not like that everyone is doing in 6 months. But yeah, people are doing it. You will read it, you will get his motivation there also. Okay. So yeah, that's the my last advice to everyone here, that please start for like exploring that website. That's the my like last word to you guys. Guys, please start exploring that website. Okay. So yeah, thanks everyone for like giving your attention to this class, and we will talk about it in our next class. That will more about it. Okay. Yeah. Thanks everyone. Take care. Very good night. Have a nice day tomorrow. We'll come back on Friday. Bye bye.